In our next example here with a converging lens, and again these are thin lenses, so the equations that we have available to us are valid. When you use thick lenses, things are a little bit more complicated. We have a converging lens, same as before. Focal length is 25 centimeters, so the distance from the lens to the focal point on either side are 25 centimeters. For a converging lens, the focal length is positive, so it's a positive 25 centimeters. And in this case, we're putting the object exactly twice the focal distance away from the mirror. Not mirror, but lens, and so that's 50 centimeters. So let's use our ray diagram to find out where the image will appear. First ray will be parallel to the normal, hits the lens, and then bends or refracts so that it continues through the focal point on the other side. So this is ray number 1. The second ray is drawn through the focal point here in front of the lens, so like this, until it hits the mirror. Then it refracts or bends and goes straight or parallel to the normal on the other side. So this is ray number 2. And where the two rays meet, this is not a very thick ray, so let me draw that again. There we go. See a little bit better. Where the two meet, that's where the image will appear. And the interesting thing here is it appears that it's exactly the same distance away from the lens on the other side as the object was. So here's our image. Let's find out if that's indeed the case. So using our equation, S prime is equal to SF over S minus F. So the object distance was 50 centimeters. The focal length was a positive 25. And here we have 50 minus 25. So this is equal to, let's see here, that's 1250 divided by 25, which is equal to 50. All right, now let's say it's centimeters because all the units were in centimeters. It's a positive 50 centimeters. So first of all, we know that the distance from the lens to the image, S prime, is equal to 50 centimeters. Now it is a positive 50 centimeters, which means it's behind the lens and it's a real image. So there's really an image that forms here because the two rays do converge together behind the lens. So the image I is real. Next, we want to find the magnification. M is equal to minus S prime over S. So it's minus the image distance, which is a positive 50 centimeters, divided object distance, which is 50 centimeters, which is minus 1. That means that the image is exactly the same size as the object, and it's negative, which means it's upside down or inverted. So the image is inverted. Here you can see the case. Remember, in the previous example, when we put the object far away from the lens, the image formed very close to the focal point. And that's important in future applications, so remember that. Now we see that when we place object distance exactly twice as far away as the focal point, then the image forms on the other side the same distance away from the lens. It's upside down, magnification is 1, and it's inverted. So now we're going to continue showing some examples by moving the object closer to the lens and see what happens next.